Hi, I'm Keith, and I'm here to introduce you to a presentation I made for the February Science Teacher Conferences about talking with our students about climate change, a rather difficult topic in many ways. The presentation's way too long for this short video, but what I would like to do is just introduce you to it and encourage you to download it for yourself later on. You can download the presentation, the full PowerPoint, from my website, which is cs4s.net. That stands for Climate Science for Skeptics. I explain why it's called that on the notes page. These are some of the pages on the website, but if you go to the More tab and go down that page to For Science Teachers, you'll find links to this presentation as well as a few other things I'll explain later. The big problem in this area, of course, is that there are all sorts of vested interests involved, particularly the fossil fuel companies. In fact, one report showed that they spent something like 27 times as much as the renewable energy industry on pushing their propaganda. So I just want to declare my vested interests. Here they are. And of course, I think all of us are probably concerned about our children and grandchildren. What concerns me so much about this issue is that there's so much polarization. Each side just yells at each other. Very little listening goes on. Perhaps one of the worst examples of the polarization we see is the sort of thing that Andrew Bolt publishes in the Herald Sun. Total rubbish. Scientists would just condemn it out of hand, and yet here he is publishing it every day, well, every few days. Of course, many of our students are quite aware of the problem, and yet others are buried in their phone, probably don't even care about the issue at all. They possibly hear all sorts of rubbish, even from teachers, unfortunately. However, the scientific world is becoming increasingly concerned about the way the truth is under attack. So the question, of course, is how do we talk to our students? It's pretty serious science. It's not simple. There's lots of misinformation around from both sides. It can be scary. And sources of good science are not easy to come about, particularly for students. Almost every issue of Scientific American or New Scientist has good stuff about climate change. But how many of our students are looking at that sort of information? So how do we talk to our students about this issue? They deserve the truth. Their future will be seriously impacted by what we do now. They deserve a say. In most cases, they get little real information from home, and in fact often misinformation. So perhaps one of the ways we can get some better information to the home is through our students. So in many ways, science teachers are a pretty important factor in all of this. But we're up against this sort of thing. I'm sure you don't look at Sky News or read Andrew Bolt, you're too sensible. But unfortunately, a lot of people do, and unfortunately, a lot of the stuff that they publish filters through into social media. Andrew Bolt criticises Greta Thunberg. No facts, only emotion, no reason, a strange cult. Well, actually, most of us would accuse Bolt of exactly that. He's worried about her because she, in fact, is the one who has got the reason, who has got the facts. And of course, at times she does get rather emotional. She's concerned about her future and the future of her generation. Furthermore, her constant message is, I want you to listen to the scientists. I want you to get the facts. But back at Murdoch Media, we have all this total rubbish from Sky News, from the Australian. The Australian perhaps is even worse because it pretends to be a serious newspaper, and yet it consistently publishes total rubbish about climate. So how do we talk to our students? We want to give them the real science, but we want to avoid creating an atmosphere of despair. But there is good news, and we and they can do our bit to bring about the transformation that's needed. This way we can help create a positive atmosphere around the issue and give them hope. But before we get to the hopeful message, let's just revise very quickly a little bit of the basic science. The basic science of the greenhouse effect was worked out by Eunice Foote in the 1850s, pulled together by Arrhenius at the turn of last century, and it's been well known ever since then. To cut a long story short, of course, the greenhouse effect basically is worth about 33 degrees. If we didn't have a greenhouse effect, then life on Earth couldn't exist. But of course, the main source of the greenhouse effect, carbon dioxide, has been increasing ever since industrialisation. Started about 280 parts per million many years ago, but we've exceeded 420 parts just recently. And the bad news, the rate of increase is still increasing. The current greenhouse effect or the current CO2 in the atmosphere has increased by 50% since we started pouring it into the atmosphere. Here's a slide that I'm not going to spend too much time on now, but I think it's a really important one. A lot of people think the Earth's climate's pretty stable. After all of human history, it's been pretty much the same. But if we look at the big picture, the Earth's climate has gone between a hothouse Earth and a snowball Earth. And when that happens, the sea levels go up and down about 100 metres. But even just looking back at the relatively short time span of the last interglacial, that's only 125,000 years ago, nothing much in geological terms, the temperature was about the same as it is now. In other words, about 1 degree hotter than last century, but the sea levels are about 8 metres higher. But if we go back to the Pliocene, for 2 or 3 million years ago, CO2 levels pretty much the same as now, but sea levels something like 30 metres higher. So what's been going on for the last 100 years or so? Pretty clearly there's a very strong link between temperatures and CO2 levels. And the problem, of course, is that those CO2 levels are still going up, and of course we have to expect temperatures to go up in line. Fortunately, we've had La Ninas for the last 2 or 3 summers, but what's going to happen when we get the next El Nino? What's that temperature going to be? Getting on for 1.4 degrees hotter? Clearly, from the way we're going at the moment, it's going to be pretty hard to avoid getting to 1.5 degrees, even by 2040, much less 2050. So where are all these emissions coming from? This is perhaps a bit of an older graph, but hasn't changed very much. This is the problem. Most of them from electricity generation, coal burning and so on. Direct combustion, that's our gas stoves and our gas hot water systems. Transport, of course, a big one. A lot of direct combustion from industry. Waste and fugitives are a bigger one. Agriculture, of course, all those cows. Fortunately, we have had some success in reducing forestry emissions because we've stopped cutting down trees so much. And in fact, because trees are growing again, the land use contribution has actually become a little bit negative. Here's another graph showing how things have been changing. You can see basically there hasn't been a lot of change at all. There was, in fact, a little drop along here when we had a carbon tax, but of course when Abbott abolished that, up they went again. Fortunately, electricity emissions have been going down a little since then because we've had more and more renewable being put into the system, but basically the picture is pretty much the same. We've had a 20% drop over the last couple of decades, as Morrison was very keen to tell us, but in fact it had nothing much to do with him. It was mainly because Queensland stopped cutting down trees so rapidly. This graph only goes up to 2020 in the middle of COVID, but unfortunately, as you can see here, things have not continued to decrease. In fact, there's been an upward trend over the last couple of years. Of course, if we look at the big picture, we in Australia, almost the worst in the world per person emissions. Saudi Arabia is a bit more than us, I think, but almost all countries are less than us, even the US and Canada and Russia. Of course, China's been coming up, but of course a lot of that is due to the fact that they're making the stuff that we buy. But notice countries like UK, Denmark, Chile, France, Sweden, they're all way lower than us. And then on with the science a little bit. You're probably well aware of the fact that scientists are very concerned about the possibility of tipping points. We don't know whether we're going to go over these tipping points. Here are a few of the possible problems. Just recently, of course, there's been quite a bit in the scientific journals about Antarctica. Ice is melting there more rapidly than it ever has in the past. There's a lot in the scientific literature about tipping points. Here's just one article you might like to have a look at later on, pointing out that even if we reduce emissions, we still may well pass thresholds that, if crossed, could prevent stabilisation of the climate at immediate temperature rises and cause continued warming on a hothouse Earth. It's a diagram that I'm not going to go into a whole lot of detail, but I suggest if you download the PowerPoint and have a look at it, it sort of illustrates the situation we're at. We're at a sort of tipping point. Are we going to continue on down towards a hotter Earth, or are we going to stabilise the climate? Here I'm just going to flick through the next few slides, but basically it's a few suggestions about where you can find some good scientific information, particularly for teachers, and in fact some of it is accessible to kids. So that was a rather quick flick through some of those slides, but you can look at them in more detail if you download the presentation on my website. And that little graph at the bottom basically sums up, it's Ross Garnaut, sums up the simple fact that, okay, it might cost us a little bit more at the moment if we take steps to mitigate climate change, but in the long run, it's going to be well worthwhile. I'm sorry to dwell on this again, but despite all the work of thousands and thousands of scientists, Andrew Bolt can come out with his rubbish. Just look at this rubbish. The government babbles about making us a splash to save the planet, even though there's no climate crisis and nothing we can do can stop it. Global warming is the left's new religion, an excuse for socialism, as well as for your soaring power bills. Apparently hasn't heard that there's a war in Ukraine and the gas companies are making a fortune out of it and charging us a whole lot more. At least some people are aware of the fact that the Murdoch media is a hub for climate misinformation. I'll leave you to look at that in some detail later on. Here's an article in Science magazine, the American Association for the Advancement of Science, talking about the fact that science is basically under attack, and we scientists and educators must do a better job of explaining how science works to the public, as well as to policymakers and leaders. If only we could. In the same issue of Science, a very interesting article titled Science, Misinformation and the Role of Education. And it points out that although as scientists we might want to check the currency, relevance, authority, accuracy and purpose of an article, these techniques are beyond the average student. But what they can do is what I'll show you in the next slide. They can look at the source of information. Is the author credible? Are there no conflicts of interest and so on? You can look at the rest. Does the source have expertise to vouch for the claim? And is there consensus amongst the relevant scientific experts? Here's an article that was in the Australian 2 or 3 years ago by Ian Plimer, who basically rubbishes the idea that climate change is a problem. But if we do a little bit of Googling, if we come up with plenty of information, plenty of suggestions that Ian Plimer is not a reliable source on climate. And I'd like to point out Climate Feedback, which is a very good website and in fact analyses articles such as the one that Plimer wrote and assesses it. And you can see there that their assessment of Plimer's article is that it has no scientific credibility. On the other hand, if we were to look at an article, say by David Caroli, we would very soon find that he's an internationally recognised world leader in climate dynamics and climate change science. Plenty of evidence to show that he, in fact, is somebody we can listen to. Now getting back to the question of the good news, here are a few examples of the good news that we have seen recently. You won't have seen very much of it in the press, unfortunately, but it is out there. So in Melbourne University, together with Queensland University and Princeton University, have published a study called Net Zero Australia. And it's a very interesting read. I can't summarise it all now, but basically it's saying that yes, we can do a lot. Similarly, a group of scientists, mainly associated with the Climate Council, updated the last Climate Change Authority's emission reduction target report. There's beyond zero emission, published a number of very interesting studies about what we can do. And Saul Griffith, quite a popular book that you can get hold of easily, How to Electrify Australia's Future. But the one I want to talk about mostly, briefly now, is Ross Garnaut. He published a book called Superpower, Australia's Low Carbon Opportunity, back in 2019. He came up with this climate change fish back in 2008, in which he pointed out that the cost of acting was considerably higher than the cost of climate change at that point. But since 2008, in fact 10 years later, it was now in 2018, the cost of mitigation had come down a lot. And of course that's because the cost of solar panels and wind has come down a lot. And yet the cost of climate change, the blue line, is going up and up and up. And we need to get acting as soon as possible. But just last year, Ross Garnaut published this book, The Superpower Transformation. In fact, he has about the first 100 pages, but the rest of it is by various experts in the field. And I'll show you very briefly what this book is all about. Australia could become an energy superpower, could export energy, export green metals. It can replace the decreasing amount of dollars being earned from fossil fuels with an increasing dollars from green energy materials, and create millions of jobs. Furthermore, Australia could help reduce the world, decrease emissions by 8%. Yeah, that's 8%, despite the fact that we're only 0.3% of the world's population. So here's, very briefly, you can have a look at this in more detail later, but very briefly, Ross Garnaut's introduction. The second chapter is about the carbon budget, and by a group of authors who know what they're talking about. The carbon budget is the answer to the question, how much more carbon can we, or carbon dioxide, can we put into the atmosphere and stay below 1.5 degrees? There's been quite a lot of studies on this, and they come up with quite different results. You can see some of them here. Some are saying that it's too late, we've already gone past that point. Others are saying that, well, maybe another 4 or 6 or 800 gigatons of carbon dioxide before we pass 1.5 degrees. And of course, in practice, this is the picture that results from all that. Had we started back in 2016, perhaps we could have followed that blue line down to zero emissions by something like 2045. But the longer we leave it, clearly the steeper the drop. And that, of course, is our problem. At this point, we are looking at a very steep drop if we want to keep the climate below 1.5 or even 2 degrees. Now in the book there are a lot of pretty complicated looking graphs that I don't have time to go into now, but I'll just very quickly show you a few. Basically the message, of course, is that if we want to keep warming to less than 2 degrees, we've got to cut emissions according to the blue line in the right hand graph much faster than most of the predicted ones. But of course we saw in COP27 that basically we've flinched out on phasing out all fossil fuels. The explosion in the number of fossil fuel lobbyists at COP27 ensured that there wasn't anything too serious came out of it. This graph is rather interesting. It shows you that high-income countries like us have got to reduce our emissions down to zero pretty much by soon after 2040. Of course, it's harder for China, Russia and other middle-income countries, and certainly harder for India and lower-income countries to do that. So if we want to give them a chance of it, we have to cut our emissions much more rapidly. Here's a little graph pointing out that what Morrison proposed was basically useless. The Albanese government have proposed something a little bit better, but what we really need is something more like 70 or 80% cuts by 2030. I'm not going to go through all these numbers right now. You can download the slide and look at it later on. But basically, the message is that if we are to have a reasonable chance of staying below 1.5 degrees, well, we've got to cut emissions by around 7.5 years. Or if we want a not so good chance, 17 years perhaps. In either case, it's a very challenging task. Another chapter in the book is by Mike Sanderford. It's got a big table of all the critical elements needed for clean energy production. He points out that in Australia, well, okay, some of them we don't have much of, but a number of them we have significant reserves, and a number of them we have not only significant reserves, but we already have the production in place. Funny looking graph, but basically this is telling us that instead of exporting processed ore as metal, lately, over the last couple of decades at least, we've been just shipping out the ore and, of course, then importing it as metal. Other sources of CO2 emissions include particularly, well, making steel, as we've just been talking about, making chemicals, and making cement. Here's a Chinese steel plant. Of course, it's not the steam that's the problem, it's the CO2. Over in Germany, they've already built a steel furnace that runs on renewable hydrogen, a world first. I'll leave you to look at this diagram in more detail later on. Back to the book, Chapter 4 is on decarbonising the electricity system, how we can do this. We've made some good starts. We are increasing the amount of renewable energy through wind and solar, both utility and rooftop. I have to apologise for the jerkiness of this presentation. Sometimes PowerPoint moves on to the next slide and sometimes it doesn't, and I have to pause and move it on manually. I'll leave you to look at this in detail later, but basically the message here is that we're still generating electricity from about 65% fossil energy. But we have huge solar potential. That little area in the middle of Australia, that's 125 kilometres aside, if that was covered in solar panels, it would supply all of our energy, not just our electricity, but our fuel and gas and all the rest of it, well, as electricity. On the other hand, countries like China, Japan and India have got a much more difficult job. They would have to cover 4%, 10%, 8% of their area, even to supply half of the energy that we do. The other thing, of course, that we've got is a lot of potential for wind energy. In fact, The global potential for wind energy is illustrated here, and that red line is ours. It's huge. It's about 20 times our current use of all power. But we haven't made much use of it. In fact, countries like Denmark and Sweden have built about 3 times as much wind energy as we have. Getting back to the superpower transformation, there's a whole chapter on the potential for hydrogen. If hydrogen is regenerated renewably, it can then be used, for example, to make steel from iron ore, and various other uses which you can read about if you go to the book or go to the PowerPoint presentation that I've been talking about. But to cut a long story short, they're looking at the need to increase the amount of hydrogen we generate by about 30-fold from today's level. If you think of it in terms of total energy, that's about 6 times as much as today's total energy. So that's a lot of hydrogen being generated. Very briefly, here's a quick glimpse of some of the things that Frank Giotto talks about in that chapter. There are various colours of hydrogen. Black hydrogen, of course, is when they produce it from black coal. Green is when it's generated by renewable electricity. These graphs are all a little bit complicated. I'll leave you to look at them in more detail later. But basically they're talking about the cost of generating renewable energy and pointing out that in fact it's for hydrogen particularly it's coming down a long way. Very interesting talk you can download from Melbourne University Energy Institute about green hydrogen as an alternative to natural gas. Have a look at the website on the bottom of that slide. Getting back to the Melbourne University study, the Net Zero Australia one, here's a little about how they see producing all that solar energy to make that hydrogen. Here's the what we could be doing in 2030, 2040, 2050, building very big solar energy arrays around the particularly around the top northwest of Australia. And of course, sending some of that energy to Singapore directly. You've no doubt heard that there's been a bit of a spat between Twiggy Forrest and Mike Cannon-Brookes about all that, but it's certainly a feasible thing to do, but of course very expensive. And lastly, the potential to actually draw down carbon dioxide in Australia. This rather complicated looking map points out that if 10% of the cropland and pastures became mallee cover, it would sequester about 18 million tonnes of CO2. And of course, mallee covers hardly dense vegetation. So summing it all up, this is how Ross Garnaut and co have decided that we could reduce the world's emissions by about 8% by cutting our own emissions to zero, by exporting renewable fuel, by exporting electric power to Southeast Asia, by exporting green metals and sequestering carbon dioxide to land. And of course, don't forget to go to ces4s.net and you can download the presentation that you've had a very brief look at here. Thank you for watching.